Welcome to the video on electrolytes and non-electrolytes. So first we just have to discuss what these two terms mean. A substance that conducts electric current in water is called an electrolyte. One that doesn't, so the opposite, does not conduct electric current in water is called a non-electrolyte. Okay, and so what we also talk about with respect to electrolytes and non-electrolytes really all has to do with charge. Okay, so if a compound will what we call dissociate into ions, then it will conduct electricity. Okay, so in order for a solution to conduct electricity, it must have ions. So that is the biggest thing. So if you look here, we have salt, Na plus Cl minus. We know this as an ionic compound, hence the word ions, right? So when this dissociates in water, we place salt in water, it dissociates, meaning it breaks apart, and it bonds, or it attracts to the water, and it breaks apart. Okay, and so we have chloride and we have sodium ion. This is called an electrolyte. However, if you take hydrogen peroxide, this is a covalent compound. This is not ionic. And as you see, these are just molecules. We do not have ions present. Therefore, it is a non-electrolyte. So, I just said this, but wanted you to see it clear. In order for a solution to conduct electricity, it must contain ions. So if you have a strong electrolyte, then it means that the compound dissociates completely, breaks apart into its constituent ions in water to form ions. A weak electrolyte may dissociate partially in water to form some ions, but leaving most uncharged molecules. And then if you have a non-electrolyte, that means it does not dissociate at all. It stays intact as molecules, and these do not conduct electric current. Okay, and so here's a nice table that gives you, and if you notice here, and so this is ones that we focus on the most, these are ionic compounds here. Okay, well, everyone except for this HCl, okay, but NaCl, KOH, okay, they have a metal, KBr, metal, and a non-metal. Okay, therefore these are strong electrolytes. This is hydrochloric acid, so we saw in a previous chapter how it will react with water. Okay, and so it also does an acid-base reaction and dissociates in water as well. Okay, these are molecules. There's ethanol and hydrogen peroxide. Okay, these will not dissociate. An equivalent EQ or EQV is the number of moles of a charge that a mole of ions contributes to a solution. Okay, so it's kind of wordy there, but what it really means is that if you know the ionic charge of a metal, okay, then you know that 1 mole of it is going to contribute 1 equivalent of that charge. So if you think of sodium, it's in group 1. We know it forms a +1 charge. Therefore, because it forms a +1 charge, it has 1 equivalent. So that 1 comes from its charge there. If you have calcium, it's in group 2. For every mole of calcium, it always forms Ca2+. Okay, that means you have 2 equivalents of the ion because you have 2 ions, right? So it's going to contribute 2 ions to the solution. Here we have a negative charge. Same thing as a -1. Therefore, there's just 1 equivalent. So you just look at the charge. Here, phosphate, we have a 3. So we have 3 equivalents. Okay, so that's just the mole of ions that it contributes to a solution. Okay, so we think about a problem with this. In my class, we don't focus a whole lot on this, but I do want to just show one problem. we have an intravenous aqueous sodium chloride solution that contains 154 milliequivalents, doesn't matter, equivalents, milli, per liter of sodium ions. We want to know how many equivalents of sodium ion is a patient given in 800 milliliters of a solution. So the first thing that I see here is that I have milliliters and I have liters. So I'm going to need to relate these two. Okay, so I'm going to convert milliliters to liters. Okay, at this point you may just be able to go ahead and you look at milliliters, you know you've got to move your decimal back 3 places to get 0.800 liters. All right, we divide by 1,000 to get to liters from milliliters. Okay, so that's going to be the first thing that I do, and then I'm going to relate my two quantities I'm given here and make my units cancel. Okay, so I have 154 milliequivalents of sodium per liter, or I can flip that over. Those are my conversion factors. I have 1 liter, 1,000 milliliters. Hopefully we all know this, 1,000 milliliters per 1 liter. Okay, I'm going to have to choose these two here so that my units cancel. So I take my 800 and I divide it by 1,000. So you may be able just to do that in your head or on paper. Just basically you move your decimal place over to 0.8000 liters. Okay, but if not, now I'm in liters. So then I multiply times my 154 milliequivalents per liter. Okay, milliliters cancel, liters cancel, and I'm left with 123. Okay, so to answer our question that we were asked, okay, this patient, this patient's given 800 milliliters, then we know that they are receiving 123 milliequivalents of sodium ion. All right, I hope this helps. Thank you.